Very good morning, each and every one of you, those who are all online, trying to learn mathematics. A very warm welcome. It's a very hot day also. But happy Moatsu to each and every one of our friends. A very happy Moatsu. Kimikali, Mimongla, Yangersinla, Takojongla, Himsunongla, Amen, Akamsangla, Ashlik, the afterlife, Intiala, Imnasinla, Imsotila, Petigrendo, Nangshibanla. Very good morning to each and every one of you. In the meantime, as we just wait for a couple of minutes. Yesterday, if you remember, we had done matrix addition, operation on matrices, addition and subtraction, scalar multiplication of matrices. So slowly, step by step, we are learning, I am sure that we are beginning to construct matrices slowly and slowly. So we have already learned how do we add or subtract matrices, how do we multiply a scalar with a matrix. And at the last part of the video, yesterday's session, we also learned how do we really multiply matrices. So today we'll be learning more on multiplication of matrices also. Plus we will be of course solving the exercises, that is exercise 3.2. So there are plenty of problems in exercise 3.2. We will try to solve as many as possible today also. So that will give us a very clear concept. It will definitely build our concept on matrices once we start solving the exercise, because that exercise will contain problems on addition, subtraction, scalar multiplication complete. So in the meantime, you can maybe write down some of the properties that we have here with matrix multiplication. Nanila, Walu, Kimsunala, Chongpongsen, Chumajongla, Hilal, Intisana. A very good morning again to each and every one of you. Tinutamse. It's good to see that many of you are taking these classes very seriously. As I earlier had said once, the number of students that I have, the more encouraged we are to give you what we know. So it gives us pleasure in sharing our little knowledge that we also have with you. So it's good to see that so many are eager in learning. And that's why even on a holiday, even on a weekend, I'm conducting classes just looking at your enthusiasm. So let's keep on encouraging each other like this, so that at the end of the day, we will all benefit from each other. I will also learn, you will also learn from me, and I'll also learn from you. So at the end of the day, we will all benefit from each other. Don't forget to like the video also. That's also important. And please do share this channel also, okay, with your friends also, those who may be facing problems with these online classes in their respective schools or places. Please do kindly share this channel too. Alright then, so let's begin now with the classes. The next session, this I think will be our fourth session, isn't it? Yeah. So let's begin. I've written down some properties. So as mentioned earlier, when we first started matrices, I told you that matrices, of course, this is just the beginning of learning matrices. Whoa, I've got so many likes today, almost everyone giving me a like, so that's again very nice. Thank you. Anyway, so as I mentioned earlier that Matrices, of course, this is just the beginning of matrices. We'll be learning more about matrices in the days to come. I mean, in the years to come when you go for higher studies, like especially in engineering classes and all. No? So here in class 11 and 12, here we're just here to learn the basics, the concepts on how to do matrices, how to deal with matrices. So we'll not be really going in depth with the properties and all the other stuff with matrix multiplication. In depth study, if you wish, you can do if you are preparing for this JE and advanced JE and JE mains and all. You can do in-depth study if you are planning for those. But for basically for board examinations and all, we will just focus more as of now. We will focus more on solution of the problems. Then definitely, if everything is all right, I'll be very soon starting another series of JEE preparations for all the students. So detailed concepts, detailed discussions of each and every topic will be done in that particular series. So you can follow those videos also, so that you can prepare simultaneously in advance for your engineering and medical examinations also next year. Of course, medical examinations, physics only, but physics I'll not be going into now because mathematics still there's a lot to be done. So I'll be focusing more on mathematics only, so basically engineering students. Alright, so the first property that we have seen here, some properties that I've written down for you. Yes, so the matrix multiplication is not commutative in general. So yesterday, as we have seen, A into B, if it exists, doesn't mean that B into A will also exist. We discussed about that yesterday, right? So it's commutative, sometimes not commutative, so it depends. Similarly, even associative property also, it will depend on whether this matrices exist or not. If AB into C, and A into BC, if these products exist, then only this associative property also will be fulfilled. Yes, third one, the product of two non-zero matrices. The product of two non-zero matrices can be a zero matrix. So it's not necessary that you have to only multiply zero matrix with a matrix and only you will get a zero matrix. No, the product of two non-zero matrices can also result in a zero matrix. Okay, all right. If you remember yesterday, what was the condition? Let's begin just a quick recap of yesterday's class. We discussed about addition. We started with addition. So when was addition of matrices possible? Addition of matrices was possible only when the two matrices are of the same order, only when they are conformable for addition. Scalar, same for subtraction also. We have seen negative of a matrix also. Scalar multiplication, when we multiply a scalar quantity to a matrix and each of the corresponding elements will get multiplied, of the matrix will get multiplied. That we have studied. And matrix multiplication, two matrices are said to be conformable, if you remember. Conformable for multiplication if these are two rows, first row, if these are two matrices, first matrix, second matrix, then if the number of columns in the first matrix is equal to the number of rows in the second matrix. And how to find out the order of the new matrix, that we have seen yesterday in yesterday's class. You can just check those videos again. So that's one good thing about these videos and all. Every now and then you can just go and recap and revise. Okay, so that's one advantage which you should really make use of. Another property will be the existence of, this is not the exhaustive property, okay, all these properties, there are more properties also, definitely. Existence of multiplicative identity, that is like if A is a given square matrix, condition is that if A is a given square matrix, and I is an identity matrix. If A is a given square matrix and I is an identity matrix, of course, of the same order, as A, then we have, or we can have, or when we have A into I will result in I into A will be equal to I. That means I is the identity matrix. That is also possible, existence of identity. existence of zero matrix also possible if A is a given square matrix and O or capital and O is the null matrix and O is the null matrix of the same order as A, then of course O in zero null matrix into the matrix is also same as the matrix into the null matrix. Result of course will be zero. That's the existence of zero matrix. So identity matrix also does exist and zero matrix also does exist. So these are some basic properties of matrix multiplication. This is going to be another important stuff again. Positive integral powers of a square matrix. That is, most of the students, of course, they commit mistakes here. They assume that, okay, like for example, if A is any given matrix, square matrix for us, then how shall we calculate A square? So what most students generally have the confusion is that A square, what they will do is they will just square the corresponding elements of the given matrix. Absolutely not. No. A square, the only way you will be doing is A into A. That is what you will be doing. That means you will be multiplying. That's the concept of square and cubes and all, isn't it? Similarly, A cube will be simply A into A, or in other words, A squared into A. And likewise, A power 4, A power 5, 6. Of course, those kind of matrices will not be there. The higher powers definitely will not be there. But yes, it will proceed like that. Okay, so this is one thing that you should always understand. And try not to change. I mean, don't change it, okay? Don't change it. Alright? Some actually still try. Like, I'll just give it a try. No, it's not possible. That is mathematically not correct. So that's not possible. Alright, so these are some properties, but as I say, these are not the these are properties are not exhaustive. There are more properties, definitely, but I think that's the basic. You can read the textbooks also. Yeah. Yasuponglamla, Utimongla, Sangita, Sunjumi. Yeah, good morning to all of you. Good to see all of you here. Alright, now let's go to exercise. Without wasting much time, let's go to the exercise 3.2. Exercise 3.2. So some of the basics of matrix addition, multiplication, subtraction, scalar multiplication all are done. Now let's move on to the exercise where we will see how things are solved. So since most of you were sharing with me that you still haven't had your textbooks and all, of course you can download PDFs as of now if the textbooks are not available in the market due to the lockdown and all this crazy things happening around us. You can always download. I'm sure the PDF download textbook, of course it will consume a lot of, I'm sure, some of the memory, but still then. Find each of the following. Find each of the following. The first one is find A plus B. The first question is find A plus B. So let's just add the matrices. That is okay. First question, so I'll just write in all the terms. So A plus B, two corresponding elements, if you remember, right? We'll be adding the corresponding elements of this. So 2 plus 1, that's 3. 4 plus 3, that will be 7. 3 minus 2, that's going to be 1. No, plus minus minus. 2 plus 5, that will be 7. Alright, the next question, A minus B. A minus B, yesterday we have seen that we have used the negative of a matrix, but that was just for introduction and in detailed description and all, but you can just subtract also as we start with the exercise and all. You can just go for subtraction, it's all the same, okay, it's all the same. So 2 minus 1, 1, 4 minus 3, 1, 3 minus minus plus 2, so 3 plus 2, that's 5, 2 minus 5, that's minus 3. Basic steps. Second, number 3, the third question is 3a minus c. Calculate 3a minus c. So that's going to be like 3a minus c. Minus 2, 5, 3, 4. If you wish, you can do it like the way we have done yesterday also. No problem, no harm done. Okay, no problem with that also. Regarding this negative matrix. So that's going to be 3 2s are 6, 3 4s are 12, 3 3s are 9, 3 2s are 6. Minus 2, 5, 3, 4. So subtracting. Result 6 minus 2, that's plus 2, so 6 plus 2, 8. 12 minus 5, that's 7. 9 minus 3, that's 3, isn't it? Yeah, 3. 6 minus 4, that's 2. So 8, 7, 6, 2. 8, 7, 6, 2. You done? Alright, the next one is number 4. So the next one is, yes, finally the product A into B. So 2, 4, 3, 2 into 1, 3, minus 2, 5. So finally the product. Are they going to be conformable for multiplication? Yes, definitely. Because we don't have to check also, because these are matrices of the same order, 2 by 2, 2 by 2. So resultant matrix also, as I said, will be of the same order, 2 by 2 only. So yesterday the hint that I gave you on how to multiply, A1, 2, 2, 1, 2, 2. So now let's proceed one by one. That is, first one is first row, first column. 1, 1, isn't it? Row, column. First row, first column. So that's going to be like first row, first column. So let's add the corresponding rows and elements, first row and first column. So like 2 into 1. I'll just write here 2 into 1 plus 4 into minus 2. Next, second row, first column. Second row, first column. Corresponding elements you will multiply and add. 3 into 1 plus 2 into minus 2. Next, first row, second column. First row, second column. Again, 2 into 3 plus 4 into 5. Second row, second column. 3 into 3 plus 2 into 5. The value will be 2 1s are 2 plus 4 2s are 8. That's going to be 10. 2 3s are 6 plus 5 4s are 20. 26. 3 1s are 3 minus 4 minus 1. 3 3s are 9 plus 10 19. So this is our resultant matrix. Minus 6. No, sorry. This is first row, first column. So I made a mistake here. 2 1s are 2. 4 into minus 2. Sorry. Minus 2. So that's like 2, 4 2s are 8. 2 minus 8. This is going to be minus 6. See, careless mistakes, as I say, it happens to each and every one of us. We have to be very, very cautious. Alright, the next question is, good morning, Chugamalla. Number 5, that is B into A. So number 5, again, definitely again, this also will be conformable for multiplication because they are of the same order. So B into A, 1, 3, minus 2, 5 into A. 2, 4, 3, 2. So again, let's proceed. Order again will be of the same order, 2, 2. 2 by 2. So that's again first row, first column. So 1 into 3 plus, come on, 1 into 2 plus 3 into 3. Next, second row, first column, minus 2 into 2 plus 5 into 3. Next, first row, second column, 1 into 4 plus 3 into 2. Second row, second column, minus 2 into 4 plus 5 into 2. So this is going to be 2 plus 3 3s are 9. 2 plus 9, 11. 4 plus 6, 10. Minus 4 plus 15, 11. Minus 8 plus 10, 2. I guess everything is fine there. Yeah. Okay? Alright, let's move on to question number 2 then. Question number 2 is compute the following. Compute the following. So I'll not be doing all because these are simple questions. So I'll just pick up some questions and do, like maybe I'll just pick up number 3. Minus 1, 4, minus 6, 8, 5, 16, 2, 8, 5 plus 12, 7, 6, 8, 0, 5, 3, 2, 4. So that's just about addition. So let's just finish this off quickly. Minus 1 plus 12, 11. 4 plus 7, 11. Minus 6 plus 6, 0. 8 plus 8, 16. 5 plus 0, 5. 16 plus 5, 21. 2 plus 3, 5. 8 plus 2, 10. 5 plus 4, 9. So that's why I was telling you, matrix is simple, just about our arithmetic. Now, but sometimes we take it so lightly that it can just completely mess things up because, as I mentioned, these are just small questions. One mistake that you do with any one of the elements, then the whole of the solution will go off. So we have to be very cautious. Simple, but it can be very dangerous. Small but effective, something like that. All right. Okay, another question we shall do. Cos square x, sin square x, sin square x. Yes, trigonometry exists even in matrices also. There is no escaping trigonometry. So that's why I was telling you last year also. Please, trigonometry, do it properly. If you haven't, then take this time to study trigonometry properly. You will find it everywhere. There is just no running away from trigonometry. So let's begin. Cos square x plus sin square x. Sin square x plus. Arrange it properly, okay, when you write, not just randomly. Rows and columns, elements should be properly arranged and written. Otherwise, you will end up confusing yourself, and that is the last thing that you would want. Let the questions and the textbook confuse you. You don't confuse yourself. All right. Okay, moving on to the next question. Again, that is also compute, but this time it's about multiplication. Compute the indicated products. Just compute. I'll just not write down the question. Okay, like number 2. I'll start with number 2. 1, 2, 3. 2, 3, 4. So we have a row matrix and a column matrix here. What do we have? We have a row matrix and a column matrix. Now let's see how do we solve this. Is it going to be conformable for multiplication? First one, let's see. First one is like 1, 2, 3. So we have 3 rows and just 1 column. Second matrix, we have 1 row, 1, 2, 3. 3 columns. So as I mentioned, yes, number of columns is equal to the number of rows. So definitely they are conformable, and the order of the new matrix will be a 3 by 3 matrix. So our 3 by 3 matrix, as we all know, is going to be in this form. So we have quite a handful of a question here. 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So let us begin. So you see a very small, 2 very small matrices giving you a big matrix. But still then, stick to the basics. This is always very helpful, okay? I'm reminding you again. This will avoid any kind of confusion for a matrix multiplication. So please, in the beginning phase, please do follow this. This will really help you out. I'm not saying that without this you cannot do it. Absolutely not. As I always say in mathematics, there are many ways to solve mathematics. Every teacher has his own way. Every textbook has his own ways of representing and all. You just have to choose the best and the easiest one for you. That's all. So first row and first column. So first row, first column. So that's like, I'll just, okay, 1 into 2, corresponding elements. 2 into plus, 2 into 3, plus 3 into 4. Second row, sorry. See, even I am also making mistakes. Very sorry there. Let's begin once again. Rewind. First row, first column. Sorry. First row, first column. So we have only this. First row, first column. So that's only 1 into 2. I got carried away while talking with you guys. 1 into 2. That's all. Second row, first column. Second row, first column. We have only, see, this one, no column. C1, C2, C3. And this is R1, R2, R3. So second row, first column. This one. Second row, first column. So that's like only 2 into 2. Next, third row, first column. Third row, and with the first column. Next, first row, second column. First row, second column. 1 into 3. Second row, second column. 2 into 3. Third row, second column. 3 into 3. Next, 1, 3. First row, third column. 1 into 4. Second row, third column. 2 into 4. Third row, third column. 3 into 4. So that will give us 2, 3, 4, 4, 6, 8, 6, 9, 12. So this will be our resultant matrix. So matrix multiplication, yes, there are chances that we will make mistakes. We have to be very, very careful. Especially for us on the board, no, it becomes very distractive. Okay? I'm wrapping it off. I guess somebody already said yes when I asked, "Oh yeah, yes, it's okay." That happens. I was just trying to get that answer. Another one. 3 minus 1, 3 minus 1, 0, 2. With 2 minus 3, 1, 0, 3, 1. Are they conformable for multiplication? Let's check. What is the first order of the first matrix? We have 1, 2. 2 rows, 3 columns. That's 2 by 3. And this one we have 1, 2, 3. 3 rows, 2 columns. So definitely, yes, they are conformable. The order of the new matrix will be of 2 by 2. 1, 1, 1, 2, 2, 1, 2, 2. So let's begin. First row, this one of course we have an element, full element. First row, first column. So 3 into 2 plus minus 1 into 1 plus 3 into 3. Next is second row, first column. Minus 1 into 2 plus 0 into 1 plus 2 into 3. I'll have to wrap that part. Next will be first row, second column. First row, second column. 3 into minus 3 plus minus 1 into 0 plus 3 into 1. Corresponding elements. Second row, first column. Minus 1 into minus 3 plus 0 into 0, that's just 0, I'll just write 0, 2 into 1. If you can multiply, of course you can multiply directly also, no problem with that. Okay, I'm just giving you the steps. I don't want to be making any mistakes. So 3 to the 6 minus 1 plus 3 to the 9 minus 2 plus 0 plus 6, that is minus 9 plus 0 plus 3. This is 9 plus 0 plus 2. So the resultant matrix will be 6 minus 1, 5 plus 9, 14. Minus 9 plus 3 minus 6. This is 4, 11. I hope we did not make any mistakes. 14 minus 6, 4 and oh my, this is 3, not minus 3. 3 plus 2, 5. Done? So please do practice this multiplication properly, okay? Because you can see how it really requires a lot of our patience, concentration, especially concentration. No? Alright, now let's go to another question again. Like question number, let's say 5. If A is a matrix that is given 2 by 3, 1, 5 by 3, 1 by 3, 2 by 3, 4 by 3, 7 by 3, 2, 2 by 3. And the matrix B, 2 by 5, 3 by 5, 1, 1 by 5, 2 by 5, 4 by 5, 7 by 5, 6 by 5, 2 by 5. Question is, compute 3A minus 5B. 2 by 3, 1, 5 by 3, 1 by 3, 2 by 3, 4 by 3, 7 by 3, 2, 2 by 3. The other one is 2 by 5, 3 by 5, 1, 1 by 5, 2 by 5, 4 by 5, 7 by 5, 6 by 5, 2 by 5. Compute 3A minus B. Got it? Alright, I'll just write down here, that is, I'll rub this part, so therefore like 3A minus 5B will be equal to 3A minus 5B. A simple question, okay? So now, if we multiply, see, we have to multiply 3 to each of the corresponding element, isn't it? So 3 into 2 by 3, class 12 mathematics, so I guess we can all just straight away do this. So 3 into 2 by 3, that's like 3 cancels, so that's like 2. This will be 3 1s are 3, this is 5. This is 1, 3 cancel, 3 cancel again, 2, 3 that's 4, 3 that's 7, this is 3 2s are 6, 3 2s are, no, 3 that's 2. 1 2 4 7 6 2 2 3 5. Fine. Minus same here also. We'll have 2 3 5 1s are 5. 1 2 4 7 6 2. So this solution will be, I'll write here directly, 2 minus 2, that's 0, 3 minus 3, 0, 5 minus 5, 0, 1 minus 1, 0, 2, 0, 0. This is going to be a 0 matrix, I guess. 0, 0, 0. Yes, so what do we get? We have a 0 matrix for this particular question. All right. Okay. Let's try to solve one more question again. Simplify. This will be the last question for today. And maybe in the next session we will try to finish up the exercise. multiply cos, that's cos square theta, cos theta, sin theta, minus cos theta, sin theta, cos square theta, plus sin square theta, minus sin theta, cos theta, sin theta, cos theta, sin square theta. That will give us cos square theta plus sin square theta. Cos theta, sin theta plus minus sin theta, cos theta. That will be 0. Again, minus cos theta, sin theta plus sin theta, cos theta. That will also be 0. This one. Cos square theta plus sin square theta. So that's going to be 1, 0, 0, 1. So this is like an identity matrix of order 2. Alright, so I guess we'll wind up here for today. But yeah, the next session we will try to finish the entire exercise. So the next session is going to be definitely, I guess it will definitely a lengthy exercise. So it's going to take some time, definitely. But do come prepared mentally also for the next session, which will be where we will try to solve the entire exercises of all the problems. There are some very important problems there in that particular exercise and many things to learn from those questions. So we'll try and solve it in the next session. All right. So thank you all for joining in. Enjoy your weekend, of course. Enjoy your weekend, and I'll see you again very soon. Once again, thank you. Please stay safe. Hopefully I'll see you in a couple of days, maybe I guess Monday most probably I'll see you. So till then, take care, stay safe. Okay, all right then, bye bye.